let us look at 2018 number 6. Consider the differential equation that's given here, a slope field which is also given here on the bottom. Sketch the solution curve that passes through point 0, 2. So when you look at point 0, 2, it's right over here. But when you look at the slope field around it, it's a straight line. So in fact, the solution that passes through 0, 2 would have been simple straight line like this. Done. That was rather simple. How about the second one? And sketch another solution. This is a solution solution curve that passes through this particular point. Now, when you look at 0, 1 or 1, 0, you see that it kind of goes up this way, and then when it comes through the middle, it kind of like flattens out and goes out the other way. So something like this. Horizontal slope. So like you have to ride along the slope field like that. I made a little, came out, but that's basically what how it would have looked like. So part A was done. Part B, let y be the f of x, be the particular solution. And then basically I'm looking at the green one here that passes through 1, 0. Write an equation of the line tangent. So in order for it to find the line tangent, we need a point and we need a slope. So then slope can be found from the one that we have seen up here. That's part B, dy over dx. When x value equals 1, y value is equal to 0. So we get is equal to 1/3 times 1 and 0 minus 2 squared. So we get 4/3. Then our equation is y minus 0, which is equal to 4/3 x minus 1. Now, that's the equation that which we end up getting, but we will be using this to approximate f of 0.7. So f of 0.7 should be around 4/3 0.7 minus 1. Then this becomes 0.3, and 3 cancels out, so my final answer becomes 0.4. But in fact, it's got to be negative 0.4. So when you look at it, 0.7 is a little bit below 1. It should be around negative 0.4, I guess, somewhere down here. All right, so that was part B. How about part C? Find a particular solution. So we actually have to solve the differential equations here. I'm going to do part C over here in this case. Then first I need to separate the variables. So we get dy over y minus 2 squared equals 1/3 x dx. And then when you integrate both sides, my left side becomes, since this is a 2 and this is the coefficient of y equals 1, it's relatively simple. We're going to get negative 1 over y minus 2. If this one was a bit difficult for you to see, you could have said u as y minus 2. And then doing the u substitution would have helped as well. On my right side, it becomes x squared over 6. Okay, and then plus c. Now, then if I have to, I like to solve for y by itself here. Then what I'm going to do is, this one can be rewritten as actually x squared plus c, entire thing over 6. And I can flip one side, I can flip the other side. So y minus 2 over negative 1 equals 6 over x squared plus c. And I can multiply by negative 1. That makes this one into positive. That makes this one equal to negative. And at the end, I can have y by itself by having negative 6 over x squared plus c plus 2. Now, when I plug in 1, it should be equal to 0. So when I plug in a 1 here, it should be equal to 0. So I'm going to try to do the work on the side here on the bottom. So 0 equals negative 6 over 1 plus c plus 2. Then you can see that negative 2 should be equal to negative 6 over 1 plus c. Then we can cross exchange, hence we get 1 plus c equals 3. Then c must be equal to 2. Then our final answer becomes f of x should be equal to negative 6 over x squared plus 2 plus 2. That's basically what we end up getting. Now, that's the particular solution. All right, and then since this one was actually a sketch of the green one, you can see the domain would have been all real number, I guess. All right, with that one, I'm done for part number 6. I'll see you later.